Hello everyone, I am Osman Urbashural. I am a physics student at Bilkent University. Today I will introduce you to an experiment that I conducted on cylindrical capacitors. The main objective of my experiment was to explore how the capacitance of a cylindrical capacitor changes with its physical parameters. Like specifically the radius of the inner radius and the outer radius of the cylinders, and the length of the cylinders. By doing this, I aim to better understand the relationship between the geometry and the capacitance. In this study, I first derived the theoretical formula for the capacitance of a cylindrical capacitor by assuming that the cylinders are infinitely long. When we assume the cylinders are infinitely long, we have enough symmetry to use Gauss's law, and with using Gauss's law, I derived that formula. This approximation allowed me to simplify the electric field analysis, neglect the fringe effect, and the focusing on a purely radial field. Based on the formula, I expected to observe two main behaviors. First, as the outer radius increases, while the inner radius and the length are kept constant, the capacitance should decreases. Secondly, as the length of the capacitor increases while the other parameters fixed, the capacitance should increase. To systematically examine these relationships, I constructed capacitors by combining three different outer radius and three different lengths. This gave a total 9 different configurations, allowing a detailed investigation of how each dimensions affect capacitor. I first prepared the inner cylinders by wrapping aluminum foil around the papers in 3 different lengths. Then I built other cylinders with the varying radius using paper again. After assembling each capacitor, I measured the inner radius and the outer radius and the length precisely as far as I can. I connected the inner radius and the outer conductors to multimeter using alligator clips, and recorded the capacitance for each configuration. My results show that capacitance decreased with increasing outer radius and increased with increasing length. These trends clearly match the theoretical predictions based on the capacitance formula for cylindrical capacitors. However, when comparing the measured values to theoretical predictions, I observed that the experimental results were consistently higher than the theoretical values. This difference is primarily explained by fringe effects. Near the ends of the cylinders, the electric field lines spread outward instead of staying perfectly radial, leading to additional charge accumulation and increase in measured capacitance. Furthermore, I observed that where the length was kept constant and the outer radius decreased, meaning the cylinders become closer together, the error between theoretical values and the experimental values decreased. This happens because the system behaves more like the ideal infinite cylinder models when the gap between the cylinders is small. In addition to the fringe effect, several experimental factors contributed to make errors. The finite thickness of the aluminum foil slightly changed the effective radius, and misalignments between cylinders caused irregular spacing, and sensitivity of the multimeter because the results are very small, like picofarad or something. Then some environmental issues like the humidity, because humidity affects the E0 constant. Then some human mistakes can be counted as errors. In conclusion, the experiment provided a valuable insight into how capacitance depends on the physical dimensions and highlighted the importance of considering real-world imperfections when applying theoretical models. Thank you for watching.